When prompting AI, there are two primary approaches. The first is procedural prompting, where you dictate exactly how to execute a task step by step. Early LLMs required this level of micromanagement because they lacked robust reasoning and needed rigid guardrails to complete complex tasks. The second is intent-based prompting, where you define the goal, the context, and the desired outcome, leaving the implementation up to the AI. This mirrors how you would delegate to a capable knowledge worker. You explain what you want and why it matters, rather than dictating every specific action. In this video, we will use the intent-based approach. Modern models excel at reasoning. By providing clear objectives and boundaries rather than granular instructions, you allow the AI to determine the most effective path to the solution. I've dropped a dataset in the project named monthlysummary.csv. It's about 24,000 rows of U.S. flight performance data covering 378 airports from 2020 through 2025. If I select the file, I can see the plain text version, but I'd prefer to see a columnar output for ease of reading. I don't have Excel installed on this computer, so I'll use Kiro to help me out. I'll right-click the file name and select Copy Relative Path. Now I'll type the following for the agent. I'd like to view, and I'll paste in the path and then complete the sentence, in a columnar format. While the agent is working, let's refresh our memory by navigating to the Kiro ghost icon located in the navigation strip at the far left-hand side of the interface. I'll select Memory under Agent Steering and Skills. Note the instruction, always confirm with the user before installing any software, packages, or dependencies. Because of the instruction, the agent asks me to confirm an installation. I'll say yes. While Pandas installs, let's briefly discuss what it is and what it does. Pandas is a Python library for working with tabular data, rows and columns, like a spreadsheet. But it goes well beyond what Excel can do. It handles millions of rows, automates repetitive transformations, and integrates with virtually every data tool in the Python ecosystem. It's one of the most widely used libraries in data analysis. The agent says it's done and tells me about the metadata of the CSV file, but I don't see the actual data. The data is displaying in the terminal. I can't see it since the terminal that is currently active is PowerShell. I'll click on the terminal named Kiro, which is a command prompt terminal, and there I see the results. If your terminal panel is not displaying, select View Terminal. Let's enter another prompt. This time, instead of procedural instructions, we'll use an intent-based prompt, describing the goal and letting the agent determine the implementation. Notice what's in the prompt: the audience, aviation operations team, the quality bar, best practices, use of calculated fields, and interactivity. Also, I gave the agent permission to apply domain knowledge with the phrase, "Don't limit yourself to just what's in the data." Without that permission, the agent tends to be conservative and visualize only what's literally in the data. Notice what's not in the prompt. There's no description of visuals or layout or what fields to explore. That's the hallmark of intent-based prompting. I'm defining the what and the why, not the how. However, note the phrase, "Before you start building, tell me what options we have and ask any questions you need answered." This statement ensures the agent returns options to choose from. This will allow me to tweak the direction without getting into too much detail. The agent lists 4 technology options: Plotly Dash, Streamlit, Jupyter Notebook with Plotly, and Static HTML Report. The agent recommends Plotly Dash. Next, the agent details what it's thinking for the dashboard. It recommends various calculated fields, dashboard sections, and filters and parameters. Lastly, the agent provides a list of questions: Dash OK, Audience Focus, Airport Scope, any specific KPIs or views. I'll answer the first 2 and see how the agent handles my omissions. Number 1, Dash is good. Number 2, Operations Team. They care about delays, cancellations, on-time performance, and which airports and routes are causing problems. The agent invites me to answer the two questions I did not initially provide answers to. But when I don't respond, it just says it will use its best judgment on scope and views and invites me to steer the initial results after they're produced. A quick word on Plotly Dash. Dash is a Python framework for building interactive web dashboards. Under the hood, it runs a small web server on your local computer. When you click a filter or a chart element, the click goes to the server, Python recalculates, and the updated chart comes back to your browser. The practical implication is that the dashboard will only run locally. We'd have to deploy it as a web application to make it available to others. But for our purposes, running it locally is fine. When it finishes, the agent tells me it built a Python script, and then details the dashboard behavior by describing filters, KPI cards, charts, and calculated fields. The agent provides instructions for running the script. If I hover over the path, I can either click to run in terminal or click to copy. It also provides a local IP address. In this course, we try to lean on the agent to do the work instead of interacting ourselves with Kiro. Therefore, I'll type yes, run the script, and start the browser. As you can see in the browser, the first output isn't working. This isn't uncommon, though it's becoming less common as the LLMs get more and more capable. To address the issue, I'll simply select all the text and paste it in Kiro's prompt. The agent troubleshoots and tells me that the browser should auto-reload. The browser now displays a working dashboard. I'll interact with each of the filters. For the year range, I'll select 2021 through 2024. For region, I'll select Central before setting it back to all. Similarly, for state, I'll check Alabama and then choose Select All. Map Trend Metric is a parameter that allows me to select different measures. I'll select each one and observe that some of the visualizations update, such as the map and the line chart. The delay severity mixed donut chart is interesting in that it groups delay severity. If I want to change the number range, I can tell the agent what I want in Kiro. As I look at the other visualizations, I think there's additional things I'd like to change. One is the color scheme of the seasonality chart. Green and red isn't color vision deficiency friendly. Also, maybe I'd like to parameterize the top 15 problem airports or the top 20 states for average ground time so that the user can choose different numbers. For the purposes of this video, I'll not work through these tweaks, though an interactive workflow of going back and forth with the agent is often a good way to get desired results. Of course, your dashboard will look different. That's non-determinism. The same intent-based prompt produces different output. The framework will be the same. The interactivity will be similar, but the specifics will vary. Back in Kiro, I'll tell the agent to stop the dashboard and wrap up. Notice the wrap-up signal that will make any needed memory updates and write out session logs. An important takeaway from this video is seeing the intent-based prompting workflow in action. With a procedural prompt, I would have specified lots of details in the dashboard. With an intent-based prompt, I define the goal, the audience, and the quality bar, and then the agent handles the rest. That's the shift that allows you to tackle bigger projects without needing to know the technical details up front.